In this video, we're going to look at the power rule for exponents and the expanded power rule. The power rule says that when you have a power raised to another power, you're going to multiply those two powers. So looking at the cloud bubble on the right, we have a raised to the m power raised to the n power. So we have two exponents here, and those two exponents are going to be multiplied together. So we're going to take m times n and keep that base of a. So looking at example number 14, we have x to the fourth raised to the third power. Well, that power rule says that we're going to keep the base of x and we're just going to multiply 4 times 3. So 4 times 3 is 12, so this ends up being x to the 12th power. On number 15, we have 2 to the second raised to the fourth power. So again, we're going to keep that base of 2, and then we're going to multiply 2 times 4 is 8. So this is really 2 to the 8th power, which I can simplify further to 256. Now we're going to look at the expanded power rule, and it's basically the same thing. It's just going to tell us that the outside power is going to be multiplied by all the inside powers. So when you have AB to the n power, that means that A is going to be raised to the nth power, as well as B is raised to the nth power. So when you have A divided by B raised to the n power, both the A and the B get that n power. So that's important to remember, that that outside power goes to all the inside powers. So looking at number 16, we have 5x to the fifth raised to the second power. So it's not distributing, but you can think about it kind of like that. One thing that's important to do is to put a 1 wherever you don't see a power, so that you remember that that's the inside power, because you're never going to multiply a base times a power. So when I multiply the inside powers by the outside powers, I'll keep the base, and then 1 times 2 is 2, so this is 5 to the second power. Keep the base of x, 5 times 2 is 10. Now 5 to the second power can be simplified, so I'm going to rewrite this as 25x to the 10th. Number 17, we have 4, a to the third, b to the 10th, all raised to the third power. Now again, I don't have a power on that 4, so I'm going to write the 1 there, so I don't try to multiply the 4 times the 3. So this outside power is going to be multiplied by all the inside powers. So I'm going to keep the base of 4 and then multiply. 1 times 3 is 3. Keep the base of A and then multiply. 3 times 3 is 9. Keep the base of B and then multiply. 10 times 3 is 30. Now 4 to the third, that's a small enough number that I can convert that. 4 to the third is 64. So I'm going to write it as 64, a to the 9th, b to the 30th. 18, we have x squared, y to the third, all raised to the fourth power. So even though this is a fraction, this outside power still goes to the inside powers. So I'm going to keep that base of x in the numerator. 2 times 4 is 8. Keep the base of y in the denominator. 3 times 4 is 12. So it's x to the 8th, y to the 12th. And then on number 19, I have 2r to the second power s divided by t to the fourth raised to the third power. Now keep in mind that my 2 and my s don't have powers that I see, so I'm going to write the understood 1 power, and then I'm going to multiply the outside power by all the inside powers. Right? And I don't want to forget that denominator. So keep that base of 2. 1 times 3 is 3. Keep the base of r. 2 times 3 is 6. Keep the base of s. 1 times 3 is 3. Going down to the denominator, keep the base of t. 4 times 3 is 12. Well, then I look and I ask myself, 2 to the third, can I convert that easily? Yes. 2 to the third is 8. So I'm going to rewrite this as 8 r to the 6th s to the third divided by t to the 12th.